right, welcome back to another video. Today we're going to be discussing the importance of RAM in your system. So what is RAM? RAM is random access memory. So there are various forms of RAM. Like in this case here, I have a laptop here. And so we're going to start off with the basics. So this is what we call a DIMM, a dual inline memory module. So here, this one, there's different forms of RAM, which is, this one is what we call the half height. It's mainly for smaller computers, which, for desktops that they're what we call small form factor. They're really thin and they don't have a lot of space inside. They're the same as a regular full height. They're just literally cut in half, basically, as you can see here. So first of all, how is RAM important in the system? RAM is what basically is the high-speed memory of your computer. So when you first boot up, everything starts off the hard drive. In this case, it's an SSD, and it is then transferred to RAM. So the RAM is kind of like the bridge between the CPU and the hard drive. So let's say when you open up Google Chrome, it first grabs it from the hard drive and it then loads it onto RAM. RAM is a whole lot faster than the SSD. So when it needs to call for something, like when you press the open tab button, it'll go to the RAM and execute the command the CPU will execute the command to open the tab. It'll then go to the program that's installed in the RAM and then transfer that data back over to the CPU, and now you have an open new tab. So RAM is extremely important. If you actually start without RAM, the computer will not boot. So having the most important thing is speed and quantity. Most people and businesses really need quantity over speed. So this one came with 8, I believe, out of the factory, and it upgraded to, I believe, 16. And there's actually, on the flip side here of this motherboard, 2 others that have a total of 8. So first of all, let's start with the different types of RAM. So we have different generations. This is a very, very old one known as SD-RAM, as you can see right here. This one's very old. Very few computers use it nowadays. So then we have DDR, which I don't have a stick of at the moment. And DDR means double data rate RAM. So this is a DDR2, as you can see here. One way to tell is if it says PC2, or sometimes they even say just DDR or DDR2. So DDR means DDR, and DDR2 means it's the second generation. So here's another stick of that half height that I mentioned, which is DDR2. And then there's DDR3, which is what most computers use now, and DDR4. I don't have those sticks available right now because that's the most popular in use, and I don't have any spares. Usually when someone needs it, they go really quick. But I do, however, have it in what we call SODIMM, which is the short version of DDR. This is what you mainly see in laptops. So it functions the same as a regular size, just in a smaller package to fit in here. So here we have a DDR2 SODIMM, and here we have a DDR3, which is this one actually, DDR3, and then we have the latest, which is DDR4. So a DDR2 will not fit in DDR3, a DDR1 will not fit in a DDR2, and a DDR4 will not fit in a DDR3. None of them are backwards compatible with each other. As you can see here, they're more or less the same size, but as you can see here, if I pull up a SD and a DDR2, the notches tend to be different. And that's to prevent you from actually putting in the wrong one, because even though they're the same size, they operate differently, and they usually have more pins or less pins. And this is what we call regular DDR. So there's another one, as you can see here, where there's a missing chip. So that if that one was populated, it would be what we call ECC, or error correcting and checking. So normally you see those in servers, and a ECC version will not fit in a regular one, but a regular one will fit in an ECC slot. So again, those are usually used for either high-end workstations or servers where memory correction and integrity is of vital importance. And usually on a consumer laptop, you won't see it. You'll just see the regular DDR, and that's perfectly fine. So now that we've got the generations out the way, the second thing you need to look for is the capacity. So as you see here, back to the SD RAM, this one has 128 megabytes. So usually on the older ones, like DDR2, DDR1, and SD, they start at lower capacities because back then, because RAM is very expensive compared to your standard storage. So, you know, they had to make do with what was available. Back then, if you had a gigabyte, most computers start off with 4 gigabytes now. Back then, if you had 1 gigabyte, that would have been, you know, easily $1,500, maybe even $2,000 just to put in your computer. That's how expensive it was. But as time went on, prices went cheaper, and RAM is still one of the most expensive upgrades you could do to your computer because RAM is expensive, but the price really has come down over the decades since computers have started. So here on the DDR2, you can see we have 1 gigabyte. On this DDR, this is another DDR, this is the DDR4 actually. This one starts at 2 gigabytes. And then the DDR3 here, we have 4 gigabytes. So depending, you can only put up to a certain amount of RAM in your computer, and that's based off of how much your CPU allows. Like in this case, it allows up to 32, and the motherboard allows up to 32. So that'd be 4 8 gigabyte sticks of DDR3. So most people don't need 32 gigabytes of RAM. Usually 8 gigabytes is more than enough for your average everyday business and user, which is, you know, they go on the internet, they only have really one program open at a time, they have maybe one or two Chrome tabs open, they're basically using it for Word, nothing really intensive. So when you want more than 8 is when you usually are multitasking or video editing, or if you're a gamer, you play a lot of games. That's usually when you want at least 16, because the more capacity you have, the more of a program can be stored, or you can have more programs stored on the RAM. And since the RAM is faster than the storage, than the typical storage, the processor can grab it quickly and put it back quickly, and, you know, vice versa, which means that the OS in this case has Windows 10. Windows 10 feels a lot livelier. Switching between applications is snappy, and you can have in Google Chrome, you can have more Chrome tabs open. That's the running joke about Google Chrome, that it uses up so much RAM. So the third option here is the speed. So as we see here on the SD RAM, is they're usually in megahertz, which is 133 megahertz. Again, this is very old, so as they become newer, they become faster. So here on this DDR2, we're running here at 666 megahertz. DDR2 usually tops out at 800 megahertz, which I think this one is another, this PC3 actually is 1066, which means 1333 megahertz. So DDR3 usually tops out at around I believe 3200, if I'm correct. And here in this DDR4 we have what we call 2133. Says it right there. And so speed is not as important as capacity. So usually you want quantity because you have a lot of programs open. Normally what you want speed for is if you're running what we call an APU, which is an accelerated processing unit, where the graphics are integrated to the CPU, like in this case this one that has Intel graphics, and they share the system memory. So normally the graphics has its own form of memory. So usually when you buy a graphics card, it'll say, oh, it has like 2 gigabytes, 4 gigabytes, 8 gigabytes, etc. of RAM. So, but a lot of times it's like in the older 2009 and even the 2011 MacBooks, they share system memory. So the faster the memory is, the better that internal GPU can perform. Also, having a faster memory means it can get things from the RAM quicker. It can open and load a program much faster. But normally you never really see, the benefits of it. You mainly see the benefit from going from like 4 to 8, 8 to 16, 16 to 24. Again, capacity for most people is what you really want to go for. And again, the speed is limited by the processor and the motherboard, and in case the RAM. So if you have, let's say, a 1333 and a 1066, it'll default to the slower of the two, because the slower one can't keep up with the fast one, but the fast one can keep up with the slower one. And normally you want to keep them you want to put them in pairs, which means like these two are Samsungs right here. You want to keep them both the same manufacturer and the same speed. It's not necessary, but it's generally recommended to do that, because that way they can communicate with each other easier and there's no worrying about conflicts. So again, the speed is limited by the CPU, the motherboard, and the RAM itself. So in this case here, this one came with 8, and we're gonna boot it off, and I'm gonna show you how just 8 works on it. So we're gonna flip it back over here, turn it on for you. I know it's a weird angle, but I'm trying to do both at the same time. So it's booting up. So the specs on this computer is it has an i7-4770QM and a 512 gigabyte SSD, just to eliminate any bottlenecks in the system. So we're basically what's limiting us is the RAM. So you see it took a little bit to get here. And let me get the mouse here real quick just to verify. As you can see, even with the SSD is pulling its own weight. So as we go here to Task Manager, as you can see here, Windows acts a little funny when you don't have a lot. So here it says 8. Even though 8 to me is my recommended minimum, it is more than enough to keep up with every day. The UI is smooth, everything loads perfectly. So when you change out RAM, you have to have the computer fully shut down. You can't have it in sleep mode. You can't have it in hibernate. You have to have it fully shut down. If you don't, you run the risk of really messing with your system. And like in sleep mode, it actually saves it to RAM. So if you remove the RAM, you basically just ended whatever operation you had in sleep. RAM is also what we call volatile memory. It always needs electricity going through it. Once the electricity stops, whatever was stored on it is erased forever. That is why we have a hard drive or an SSD, like what this one has, which means that even when the power is off, the data is still saved. And we have one more thing to talk about actually on the RAM, which you see these numbers here, these three numbers, which in this case is 11, 12, and B4, those are timings. That basically tells you how fast or how slow each part of the RAM is. You also want to keep those in check, not in check, well, keep those the same. But like I said, the computer's smart enough to tune to the slowest of whichever you want. And for most people and most businesses, it's usually not important. Like I said, it's usually the quantity or the amount you have that makes the biggest difference. So now, as we flip it back over, again, you want to touch something metal to discharge yourself, is we're going to put a 4 gigabyte stick in it of DDR3, which is this one here. You always want to double check. So we're going to put it in on the bottom one right here. So when you install it, there's a notch that goes here. As you see here, this notch lines up with this notch. And for laptops, it usually goes in at an angle at first. And then you push it down, and these two tabs will slide out and then lock back in, and everything is fine. So now, let's put it back here, and we'll boot it up once again. So now we'll have a total of 12 gigabytes. 8 plus 4 is 12. Sometimes when you install RAM, it's a little slow to start off with on the very first try because the computer knows like things have done changes and it'll do a self-check. But as you see, you know, we still get to the desktop fairly quickly. And here you go. Again, usually this speed difference is more prevalent on a regular spinning hard drive, but as you know, and even an SSD will see it. So here you are, 11.8, 12, and we're operating at 16 megahertz. And as you can see, they're all the same speed at 16 megahertz actually here. So let's shut this down again to install the next one. There's a lot of stuff out. So now we're going to install the last one, which is the last 4 gigabytes, which will give us 16. Again, we do the same procedure. You line it up, it goes at an angle, it comes down. Whoops, that one didn't go in just right. There you go. And now we will flip it over once again. And boot it back up one last time. As you can see, even with the new one, it loads up way quicker on 16 than it did on the 12. And usually after the second boot up, it'll be even quicker because the computer already knows what's in it. It detected no change, and it'll just go straight to the operating system here. As you can see, that loaded up a whole lot faster. Go to Task Manager here. Go to Performance, and we have 16 gigabytes of RAM, and all 4 are used. So that's another thing. You have what we call single channel. As I'm going to shut this down one last time as we no longer need it. So when we have, I'm going to use these as an example. So if there's only one RAM stick, here, let's get this out of the way. So if we only have one RAM stick installed, it is what we have, what we call single channel memory. So single channel memory means one, basically. So if we have 2 installed, we are now what we call in dual channel. So what's the difference between single and dual? Besides the fact that there's one more. So dual is usually a performance boost where we can have, where we basically have, we doubled the amount of lanes in which information can travel from the CPU to the RAM. So think of it like a highway. So if we only have a 1-lane highway, which in case you have people going north and people going south, you're limited to basically the amount of lanes you have. So you have to wait for all these other cars to finish going before you get to your destination. So if you have one program, that's kind of slow and, eating up a lot of resources, you have to wait really for that program to finish before the other one can get to the destination. So if we put in dual channel, now we have 2 lanes, 2 going north, 2 going south. So now now if we have one going slow, we can get around him and continue on with where we want to go. So then there's what we call triple channel. So now you have 3 going north, 3 going south. So again, you can have one program in the slow lane and the other 2 will keep going. Triple channel is really not used. Mainly you see what we call quad channel, which means you have 4 information highways to get your point across. So a lot of desktop motherboards and even this computer, it has 4 slots, but it's not quad channel. It's still dual channel, which means you usually see them color coded, like one is white, the other one is, blue, and then it's white and blue. So the 2 blues are 1 channel and the 2 whites are another channel. So basically you can have usually like DDR3, I believe you can go up to 16 gigabytes of storage of RAM. So, but let's keep it simple. Let's keep them all 8. So you can have 16 gigabytes on one channel and another 16 on another. So not only do you have lots of pathways to get information, you have a lot of quantity to go with it to store large amounts of programs for whatever you want to do. Quad channel is usually for, again, servers and high-end workstations where you have a lot of information going through and you need every single bit of bandwidth you can get. So there is also a performance increase if you're a gamer going from dual to quad if your motherboard supports it and your CPU supports it. Not every CPU and motherboard support it. And but for most people, even if you do, even in games, it's a very small amount of increase that, it's not like, wow, like you noticed it. It's not like going from a Yaris to a Testarossa. You won't notice. It's not that much of a difference. So so that's the basic importance of RAM. I hope you all learned something today. And one more thing actually is, if you have a Macs, even if it's DDR3, like an example, this one, just because it's DDR3 and your Mac takes DDR3 doesn't mean that your Mac will support it. Macs usually are very, very particular on the timing, which is these numbers here, where you see, I installed in here, this one doesn't show it, is very particular about those timings. And even sometimes particular on the quantity and who makes it sometimes, but it's mainly the timing. So what may work in your Windows computer will not necessarily work in your Mac computer, but what will work in your Mac computer 9 times out of 10 will work in your Windows computer. So again, with all these limitations based on motherboard, make, model, even the year, it's important when we do upgrades here at Dolphin. That's why we normally ask, what is the make and model of the computer? Because every computer is different, and there's no sense in paying for 16 gigabytes worth of RAM when it only supports 8. So that's why it's important for us to know that information, so we can get you the best performance per what you want to spend. So again, that's basically it for this video. Thank you very much for watching, and I hope to see you all in the next one.